Good day and welcome to this video in our series teaching C#.NET for engineers. In this video we are going to take a look at lists and arrays and also basic concepts related to looping over lists and arrays. Now, lists and arrays are very important for engineering type of applications. It's probably important for any type of software application that you may write, but I have found as an engineer, I've almost never been able to write any sort of application where lists and arrays have not played a quite important role in the structuring and execution of the application. So it's one of the important building blocks that I would like you as an engineer without in-depth knowledge of C# or .NET to have already in place before we get to the other videos where we are going to demonstrate how we can put these concepts together to build real world applications. Now, lists and arrays are especially important in engineering and data applications. We need them to store and structure data when we read data in from files. They provide a structure for accessing data based on location or the index, and they provide a good starting point for us to understand loops, which is one of the fundamental building blocks of a coding structure. Now, let's just take a look at lists versus arrays. In C#.NET, you have two basic structures that you can use. They're not the only ones. There are other ones that we will discuss. Primarily, one of the very important ones is what's called a dictionary. But for now, we're just going to look at lists and arrays. And here, I'm just full disclosure, I've just put this into ChatGPT and said, give me the pros and cons of lists and arrays, because I didn't want to dream them up myself. So basically, as you can see here, C# provides two primary data structures for storing collections of elements. These are arrays and lists. Now notice that T means type. And that type, if you can think of that, you can replace that T basically just with any data type like we discussed in some of the previous videos, such as a double, a string, an integer, and so forth, right? So we've got an array and a list, and both of these have their advantages and disadvantages. A list is a dynamically sized collection. So think of it like a stretchable bag. You can put things in there, and if you want more, you just put them in and it will stretch automatically. You can put some more data in and it will stretch further. You can also remove data and it will shrink. So that is what it means to say it's dynamically sized. So as it says here on the pros of lists, it's dynamic resizing. Lists can grow and shrink without manually copying. There's a rich set of built-in methods in .NET, so you can add elements, remove, insert, sort, find, etc. They are generally a higher level of abstraction, so it's quite easy to understand a list, to understand how it actually works. They support LINQ operations. LINQ is just like a subset language in .NET. For now, let's skip that. We can come back to that later. And as we said earlier, they are better suited whenever you've got data where you're not sure how it will grow. For example, you have a collection in memory and the user can say, add new test bit or add new test data, and they add more data and you don't know how many the user is going to put in there. Then a list would be a good place to store that data in memory, and you can go and retrieve elements, the last one entered or the first one entered, etc. The downside of lists is that they are slower to access compared to arrays. Because they manage their own resizing and allocation internally, there's a slight processing overhead to accessing elements in lists. More memory overhead, and as I said, also resizing performance hit. Okay, so if you are going to have an array that of 1 million elements and or a collection of 1 million elements, and you want to loop over it and index it frequently, a list may not be the right way for you to go about it. But for something storing up to, say, several thousand elements on a modern computer, a list will be fine in terms of performance. You probably won't even notice the performance compared to an array. Okay, now we get to arrays. Arrays is a fixed size collection. So here, think of it as a bag, but the bag is a certain size. Because we know what the size of the bag is, we don't have to manage memory in such an intricate way. And so accessing elements in the bag is much faster in an array compared to lists. So like ChatGPT says here, a faster access. Since arrays store elements in contiguous memory allocations, accessing an element by index is very fast, lower memory overhead, better for performance critical applications. So for example, in Juno Cassandra, which is our deterioration modeling application for infrastructure networks, we have got arrays which are potentially very, very large, and we exclusively make use of arrays so that we can, the performance of the application is absolutely optimal for looping over those data structures. And also there's multi-dimensional support. So you can have an array, a 2x2 or a two-dimensional array, and you can also make it 3-dimensional, 4-dimensional, etc., and reference elements in those arrays very easily. The downsides of arrays, primarily fixed size. Once you have created an array, you have to set the size when you create it, and after that you cannot make it smaller or larger. So manual resizing is required, and there's no built-in manipulation methods like add, remove, etc., which makes them a bit less flexible. This is just a summary. So you will prefer an array when you have got a fixed size collection, performance critical applications, and direct memory efficiently, but you will prefer a list when you have a frequent removal or addition of data elements. So your bag is growing and shrinking, unknown or dynamic size. You need built-in helper methods for adding, removing, etc. And if you want to use link operations easily. So don't worry too much about that at this stage. So let's go over to our demo project, and we'll give a hands-on demonstration of just how to create an array, how to create a list, and how to loop over it. Okay, so here I am in my demo application. Now I'm presuming you've watched the preceding videos in which we created two Visual Studio projects. We created a library and an application, and the application has a reference to the library. And in the previous video, we created some classes in this library and we called them from my application. Now, if I go to the program file here for my application, I've just deleted everything from the previous video in here, and I just want to demonstrate for you how to create an array of a type double. And now just remember, I'm choosing type double for this demonstration, but it could be an integer, it could be a string, it could be anything. Right, so I'm going to say double, and I put square brackets like this, and I say data1, and I'm going to say this is new double, and I'm going to say it is of size 10. Now notice now this is an array, so once I declare it, that size 10, it can take 10 double precision numbers, and that's it. If I wanted to make this a list of, or an array of integers, I would simply have said integer with square brackets, and I would say data2 equals new integer 10. Similarly, I could have string like that, and I can have 10 string elements. And .NET will automatically, of course, take care of the different memory requirements of these three data types. So although all of these arrays, they are all arrays, although they all have 10 elements, their memory requirements will differ, as we discussed in some of the previous videos where we looked at basic data types in .NET. Okay, so I'm going to just use a double precision number, but as you can see here, the syntax is very similar, right? So remember, in the earlier video we said if I declare a single double number, and I say my number, then I can say this number is 3.14, like that, and that's the way I would declare a single double number. If I want to declare an array of double numbers, I will use this syntax over here to do the actual declaration of that array. Now, how do we actually set the elements in that array? So let's just delete this, and we'll focus on this data1. So if I want to add numbers to it, I'm just going to say data1, that's the name of my array, right? And I'm going to put the index, and remember I said earlier that the index is 0 based. So I'm going to say, let's say 5.678, like that. and I can add another number to that, and so forth, right? So that is the way that I would add numbers to my array. Now I've added three numbers in this array. What about the rest? Well, they are going to be empty. So let's put a debugger. This we also demonstrated in our previous video. Let's put a breakpoint and debug into this array and see what is created. So if I click here on Run Application, and then I'm just going to step over this. And if I hover now over my data1 element and I make it open, you'll see the default value for all the 10 elements have been assigned as 0. Now notice again, like I said earlier, because it is a zero-based indexing system in .NET or in C#, the last element will always be one less than the number of elements in the array. This array has got 10 elements, and therefore data1 is going to have 10 up to index 9, right? And you can see all the element values are 0. Now if I step over this, I'm assigning to the index and 0, I'm assigning a number, and I'm doing that for index 1, and I'm going to do that. Actually, I'm going to make this a 9. In Visual Studio, you can actually edit the code while you debug it, and I'll just loop over that or step over that, and let's go and investigate what this index look like, what this array looks like now. Now you can see I've got a value for 0, I've got a value for 1, and I've got a value for 9. Now if I want to try and add an element at index 10, like this, I'm going to get an error. Let's do this. I'll just drag the debugger up there and step over, and you'll see I'm going to get an error now, and the error is going to tell me there is no space at index 10. So there you get it, system index out of range exception. The index was outside the bounds of the array. So this is something that you will very often see. If you are looping over an array and you go too far, you're going to get this array, this error. So watch out for it, and you know now where it comes from. Okay, now I just want to show you a shorthand for also declaring an array, and that would be to do it like this, where you actually say double, and again you put the square brackets, and this variable I'm going to call data2. You say new double, but now instead of specifying the size, directly after that in these brackets, these squiggly brackets, you put the numbers in the array, and it will automatically be sized for you, because .NET will pick up that you've got 3 numbers, and therefore you've got an array of a size of 3. All right, now let's do one with 10 numbers, and then we'll print out those numbers in a loop. So let's do this. We're going to say double data equals new double 10, and then I'm going to do that, and I'll just put the numbers in like that. Now, and I have to put a semicolon at the end. I'm going to see if it can help me to do 1.234, comma. All right, so there's my 10 numbers, and now I'm going to write a for loop to loop them out, to print them out. So I'm going to just put for, and that is the structure of a for loop. Now again, I'm not going to try to teach you or force you to memorize this syntax. You just have to be patient and take time to learn, and it will come to you over time. If you ever get stuck and you're not sure, you just head over to ChatGPT. Let's do that. We simply head over to ChatGPT. We start a chat here, and we say show an example of a .NET C# for loop. Okay, now again, you'll see that ChatGPT is going to write me an entire program here. So I'm going to try this again, and I'm just going to say show an method only, not full program. program.cs. Okay, so there you go. It's written a little method there, and it shows me how that actually works. So that's basically what we've done over here. And now if I run this, there's my numbers printed out. Okay, so that's enough for arrays. I just want to remind you again, we can change this to text or to string, integer, etc. Quite easily. Now let's look at lists. Okay, so a list basically is just declared like this, list. And you remember previously it showed it like a T. Now that we should put a real type in there. So let's put in double data1 equals new list, and there's a shorthand way of creating a list of 10 numbers, right? And we can also loop over a list like we did earlier for. So here we are putting data.count. That's the number of items in the list, and we are looping over each of the elements from index 1 up to index just less than. So it's quite important to note that less than data.count, and I'm going to write all of those numbers out to the console. So let's run that. There's my 10 numbers, and I just want to show you a different way of doing it with a list, and that is the for each loop. So I can, with lists, I can say for each item in data1. Now this var is a generic name in C# for a variable where it will be dynamically picked up what the variable is at runtime. But I prefer always, if you know what the type is going to be, put in there it is a double for each item in data1. So this is a very neat way of actually looping over lists. And you remember when we discussed the pros and cons, we said that lists provide a cleaner syntax. It's a more a higher level abstraction than an array. So you can see here it is quite a nice way of writing out this loop. Let's run that, and there's my numbers. Now, we said earlier that a list is dynamic, so we can also do this. We can declare a new list, but we have to put round brackets behind that to indicate this is a new list, but it's empty, right? So I don't have any of those curly braces with actual values behind it. I just have it as empty. Now, if I run this now, I won't get an error, because this is actually a valid initialized list, but there's nothing in it. So if I run this, it's not going to print out anything. So let's go and manually add some numbers to it. So I can say data1.add 1.1, and I add 2.2, 3.3, and then I can print these numbers out. So let's do that. And there my numbers are printed out. And now, then let's go and add a few more. And now I'm going to remove some of the numbers. So I'm going to say data1.remove, and I'm going to remove the element at index position 2. So this is 0, 1, 2. So that will remove 3.3. So you can see that the comment here says remove 3.3, and if I loop over that, we'll see we're going to have 1.1, 2.2, but we won't have 3.3. We'll have 4.4, 5.5. So you can see how I can dynamically grow this list of numbers, and let's go and print that out. So there's the list of numbers printed, and you can see 3.3 is missing. All right, so that's it for this tutorial. So that's it for this video dealing with lists and arrays, and also the basic concepts of looping over lists and arrays. In the next video, we'll go one step further and we'll start putting together a more practical application that uses these lists and arrays. Thanks for watching.